Alright, so we're in activity 2.3.2, stopping the spread of malware, and we're going to look at a tool called Wireshark, which is really useful for analyzing network traffic. If you haven't watched this video yet, you should do that. It talks about some ways that bad network traffic could lead to disruptions to a network. We're going to use a tool called Wireshark, which is going to do something called packet sniffing, to look for special packets to see what could be problematic information that we could analyze and maybe stop. So the way we're going to do that is we're going to use a tool called ping. Ping is a tool, a command line tool usually, that generates a packet of information or packets of information, and it sends it to a computer or a host on a network, and then it replies back uh, that it's received the ping. So this is sort of like a "Hey, are you there?" type command. You send a message to a host, and if it responds back to you, you know it is on the network. Um, so the first thing you have to do is obviously open up the lab. I'm in the lab already, hopefully over here. This lab actually locks up every once in a while, so hopefully that won't happen to me while I'm videotaping. But in this lab, you're going to mostly be on this login machine at 172.30.0.6, and we're going to interact with this computer over here, but we won't actually log in like we did in previous sections where we bring up a graphical interface. We will at one point use a tool called PuTTY, which we will log into at the command line to do some stuff over on the server. So to get into Wireshark, we're going to find this blue thun, and okay, this pops up, make that go away. So here's Wireshark. You can also click on it down here in the taskbar. If you open up Wireshark, you'll see a screen that looks like this. It'll take a minute to load information. While that's loading, what it should have as our first option here is Ethernet 2, so you don't have to do anything here. Ethernet 2 is already open. This little graph here is showing you network activity on Ethernet 2. What Ethernet 2 is an Ethernet connection, which, if you don't know, is a wire that can go right into your computer that has internet traffic over it, or network traffic. If we weren't right now inside of this virtual machine, if we were running it on a computer that has Wi-Fi, you might see a Wi-Fi entry here, and you could actually see the network traffic over the Wi-Fi instead. But we're going to go over Ethernet 2. The first thing we're going to do is enter an option here called not port 3389. And the reason we're doing that is because that port is used for doing a lot of the virtual machine work that we're not interested in getting network traffic on. So you can type that in. The directions tell you to do capture start, but if you literally just hit the enter key in here, it also starts it up. Alright, so you can see that it's capturing over Ethernet 2, and we have all this information here, which is slightly overwhelming, that pops up. Alright, so we've already started everything. There's a lot of network traffic in here, so to kind of filter things down, I'm going to type in ICMP here. And don't do version 6, just regular ICMP and hit enter. What this is now going to limit us down to is only packets that our computers either receiving or sending that are from like a ping command, so an ICMP message. So right now, since we haven't generated any pings, we don't have any network traffic to analyze yet. So let's fix that. So what we're going to do is we're going to ping 172.30.0.13. Now, if you forgot, let's scroll back up here. I think it's up here. Did I lose it? Where is it? Oh, there it is. That's the IP of the server. So we're right now on this machine. We're going to ping the server, and we're going to see if it responds. So I'm going to open up PowerShell, and I'm going to run that command, and I want you to watch this window to the left. And Wireshark, we'll see what happens. So 172.30.0.13. Hope I typed that in right. I hit enter, and oh my gosh, all this stuff is showing up there. So the ping command sent 4 pings to that IP, and what you can see here in Wireshark, and I can make this a little bit bigger, is there are 8 pieces of information. And the reason there's 8 is this first one is a command that went from Am I missing the top one? Oh yeah, here's the top one. That goes from us, 0.06 or 0.6 to the server, and then we have a response ping that goes the other way from 0.13 to 0.6. Then we have another one that went from to, this happens every once in a while. But all in all, this is all the different ICMP messages that we sent. So I'll reconnect. Hopefully that will probably make me require to restart Wireshark again, which is really annoying. Yep. All right, so I'll reopen up Wireshark again. And while that's booting up, we'll keep going. So we've run the ping command. We've seen some statistics on the ping. We noticed it in the PowerShell window, and then we also saw it show up in the Wireshark window as well. Some information about what you see in there. Let me type this in again. It was not port 33, let's see, 89? Is that right? Not port 3389, yeah. Okay, hit enter to start it again. Once again, I filter an ICMP, and then in PowerShell, let me ping 172.30.0.13. And so it sends the 1, 2, 3, 4 pieces of ping information. And once again, we should have 8 commands in here, essentially. I'm not sure what this one is. Why we suddenly have an echo, another one from 6 to 37. That's interesting. But these represent all of our commands so far. Some other information that they're pointing out here, in the ping command that you saw in the PowerShell, this time piece of information says how long it took. So we're pinging a web server that's very close, so it took less than 1 millisecond to send a request and get a reply. And the TTL means how long you should essentially go until you give up. So like this is saying that the ping should go at most 64 hops to find the web server. If after 64 jumps around different routers, if it never got there, then it would give up. But it really didn't take that long to find it, so that wasn't an issue. All right, so let's sort of break down what's going on in here. So one, we already talked about this. We have a source and a destination. If we kind of break down, let's go over here. So we got the packet list, we've got request and reply, blah, blah, blah. So what we're going to look at now is the packet details. So I've got a packet selected right here. It went from my source computer to the destination server. If I expand the frame, there's some information in here that could be useful. So for example, there's a timestamp. So that tells you when the ping packet was actually created. And there's some other information here which is not quite as useful. But if you expand the Ethernet 2 section, what you'll see is that there is a destination and a source, and these have what are called MAC addresses. So right here, the destination MAC address is this funny symbol here, 02:19:98:AB:42:5B. And that is the hardware identifier for the computer that receives this packet of information. Every computer in the world, in fact, anything that has a network card, I should say, should have a unique one of these MAC addresses. So when the device is created, it should be given one of these uniquely. So the source, which is this virtual machine, it has a network adapter. This is its MAC address that's supposed to uniquely identify that computer. That's sort of important on the internet to be able to have unique identifications of different computers. All right, so we talked about the arrival time, we talked about MAC addresses. The part that's going to be a little bit overwhelming is all this down here. This is actually the raw hexadecimal information that makes up the packet. So that would be really hard for most humans to look at and make a lot of sense out of. But this is the actual data that's in the packet in a version that makes a little bit more sense to computers than it does to humans. All right, so now we're going to start attacking our network. So this sounds like fun. So the way we're going to do that, first of all, is we are going to minimize Wireshark. In fact, one thing I think I want to do is I'm going to stop Wireshark, and then I'm going to tell it to start again. And I want it to continue without saving. So I lost all my old information, but that's okay. Minimize PowerShell. We're going to open up PuTTY. PuTTY is a SSH tool for connecting securely to a server. And the server I want to connect to is 172.30.0.13. So 172.30.0.13. Port 22 is okay. I hit open. And so I'm going to log in. And my login, I think, is root. And then my password is tour. Well, that's not very secure. So root, a very common name for the user who has the most privileges on a Linux computer. And the password is TOOR, hit enter. And now I'm at a command prompt inside of the web server. So over here in the GUI, this is the local machine. I'm now logged in remotely to the web server in the command line. Alright, so I'm logged in. Okay, so now we're going to ping the local host, so the local machine, the login machine. So I'm going to do ping 172.30.06, and it's going to start sending all these ping messages. In Linux, when you start sending a ping command, it will just keep going forever unless you stop it. So if you hit Control-C, it'll stop the ping command. And if I bring up Wireshark again, you'll see that I collected all that information, all these requests that came from the web server, and then the replies that came from the local machine back to the web server. All right, so we did that. We did some analysis. It was great. Now, it's going to ask you to run man ping to find out more about ping. And that's because we're going to try to do some commands to make a ping flood. So I'll run the man ping command in the terminal. And the way you navigate through this is you hit the space bar, allow you to go down. And you kind of look at some of the options here that might be useful. A lot of it looks like it may not be useful, just sort of overwhelming. But the -F command will allow us to do a flood ping. So that'll be one that we're going to use in a minute to say that we're going to flood the network. We can also specify the interval, which is the seconds between packets. And if we decrease the number here that's after -I, that's going to mean we're going to send a lot of packets in a short amount of time. And I feel like there's one I missed in here that I also wanted to use. Is there any others? Well, the directions will tell me the one I'm missing in here, but if you hit B, it should go back. I wonder which one I forgot. Whatever. If you hit Q, it quits you out of the man pages. And let's see which ones I forgot. So first, what does -I do? It says it's the interval between pings that you're going to send. So what this command here would say is send the ping command with a delay of 2 seconds between each ping message sent out. And this is the computer to send it to. Yep. All right, so, oh, the packet size. That's what I forgot. We're going to change the packet size. So let's see if I can figure that out. So how do I manipulate the packet size? The answer is right there, but I want to find it on my own. Let's see. Preload, no. Oh, it's in here somewhere. Oh, -S, right. So that will allow me to specify how big the packet is. Okay. So we're going to run a command that has all of this in it. So we're going to flood it, so that's -F. We're going to set the interval to be 0 seconds between each send, so that'll be -I0. And we're going to do a -S 4000 to say that it's 4000 bytes. And you can see that's exactly what they have here. So I'm going to run this command. So it's ping -F -I0 -S. And how big do we want 40,000? 4,000. So 4,000 bytes is pretty big. And then I want to send it to this client machine. So 172.30.0.6. Now, before I run it, well, actually, I guess I'll run it right now. So I'm going to hit run, and what should be happening over here in Wireshark is it is freaking out. It's just getting overloaded with all of these packets that it's sending over and over and over again. Lots of information. So that could be bad. So I'm going to go ahead and stop the attack. So I hit Control C in the terminal. All right, that's done. So what we're going to do now is we're going to stop or prevent a ping flood from ever happening again against this local machine. So I'm going to stop. I think I want to stop Wireshark, right? Yeah, I wanted to stop that, making sure. So stop. Okay. So we're going to change the firewall settings so that way we will deal differently with all those ICMP requests. Because the issue is, so let me go down here into Windows and open up the firewall settings. The issue isn't so much that we're getting all those packets of ping information. The problem is that we're trying to respond to them. So if we go to the inbound rules, somewhere in here is going to be a section that allows us to control what happens when we get ICMP messages. So the section that we want is under file and print sharing. So that is here, and it's this one. The echo request, let me pull this over, ICP version 4N. Yeah, and that's one we want to disable, so I'm going to disable it over here on the right. So I've selected it, then I can disable the rule. All right, so I've disabled it, and now we're going to try to run Wireshark again. So I'll close out of the firewall rules. I'm going to start Wireshark again, and I'm going to continue without saving. So once again, nothing's coming yet. And now I'm going to run the ping flood again. And what you should notice here is I am getting a lot of information here, but all of them are going from the web server, which was point 13, to me, point 6, but I'm not responding to them anymore. And so because I'm not responding to them, the computer can just it can receive the ping, and it can just drop it and do nothing with it. Before it would receive the ping, and then it would go, all right, I got to do something with this. I have to read it, and then I have to respond to it, and that was slowing down the network. But now I'm just dropping them like they don't even matter. All right, that pretty much finishes your introduction to how Wireshark works.